Let's find the vertex and sketch a graph. That's all we really got to do. I am back again, and what I'm going to do very quickly is show you two ways to find the vertex of a quadratic equation. So keep in mind, a quadratic equation, general form, is that f of x equals ax squared plus bx plus c. So when you see the highest exponent is a 2, usually that's a good indication that you're dealing with a quadratic equation. But like I said, I'm going to show you two ways to find the vertex. And this beats just plugging in a bunch of x values and plugging them in and finding ordered pairs and seeing what's going to happen. So the first way to find the vertex of a quadratic equation like this one is simply to use a little simple formula that's x equals negative b over 2a. Now this formula right here, sometimes it's just thrown right at you. But in Calc 1, so stick around for Calculus 1, what you'll do is learn what's called the first derivative test. You'll take the derivative of a quadratic function, set it equal to 0, and solve it for x. And what you do is end up finding the maximum or minimum point, the vertex of that parabola, and it's really this formula. So you got a formula thrown at you in algebra, but in Calc 1, you should definitely verify why this is the formula for finding the vertex, the maximum or minimum value of a graph of a quadratic equation. So with this in mind, what we got right here is negative b. So since b is negative 2, the coefficient of the linear term, opposite b would be positive 2. A is the understood 1 coefficient, so 2 times 1 is 2, so we get 1. So this is nice, but this is really a twofer. I love saying that word. And what I mean by that is, not only did we find the x value of the vertex, but we also found the equation of the axis of symmetry. So in other words, this is the equation, the vertical line, x equals 1, but it's also the x value of the vertex. So what I need to do now is find out what y is equal to when x is equal to 1. So plugging in 1, I get 1 squared, which is 1, plus 1 is 2, minus 2 gives us 0. So let me go ahead and plug that bad boy. That's 1, 0. So let me put it up here, 1, 0. And keep in mind, the vertex is going to be the only point that touches that axis of symmetry, that line that cuts that graph directly in half. And you're saying, well, what do we do now? Well, let's find some easy points to graph. Looking at this bad boy, if I just plugged in 0 for x, I find out that my y-intercept is 1, pretty easy to find. So there it is right there. But keep in mind, the axis of symmetry says if there's a point here, there's the point right here, that mirror image of it. And believe it or not, this is really enough for us to sketch a quick graph of this quadratic. It goes just like that. Now, I know some of you are probably watching this. I mean, this is very basic. But this video is really intended for me to help you find that vertex. So keep in mind, since the quadratic coefficient right there, the number in front of the x squared is positive, it opens upward, but we kind of knew that once we plotted that point right there. I could easily throw in a few other points and plot them and get a nice, prettier sketch, but let me show you a second way to find the vertex of this graph, and it involves completing the square. So, what I end up doing is simply this. I'm going to slide that 1 just over a little bit because I really want to complete the square with this binomial. And to complete the square, we take half of negative 2, which is negative 1, and square it, which is 1. But if I add 1, I also have to subtract 1 at the same time on the same side of the equal sign. So be a little careful there. I added 1 and subtracted 1, which means I essentially just added 0. So now this is y equals x squared minus 2x plus 1. Plus 1 minus 1, well, if you want to put a plus 0 there, it's not anything, but this factors into simply x minus 1 times x minus 1, which is x minus 1 squared. And then if you want to keep that plus 0, you can, but here's the cool thing. Our vertex can be read right off of it. It is 1, the number that causes this binomial to equal 0. So if I plug in 1, the whole thing's going to be equal to 0, and whoa, there it is. There's your vertex. So this formula is nice. It does give you the y value, whereas this formula right here only gave you the x value. So you get the same information from both of them, just two different ways. So let's try it again. If we look at this particular function, 2x squared plus 4x minus 3, I recognize this is a quadratic equation first, and then I use the formula negative b over 2a to find the vertex. So negative 4 over 2 times 2, which is 4, is negative 1. So keep in mind, this is a twofer. This is an x value of the ordered pair of the vertex, and it's also the equation of the axis of symmetry for the parabola. So now I can say, well, let me plug in negative 1 into this, and let's make sure we do it right. Negative 1 squared is 1 times 2 is 2. And then negative 1 times 4 is negative 4. So we have 2 minus 4 minus 3. So that's minus 5. Let's double check it. That was negative 7 and then 2. So 1, negative 5. So let me plot that point. So this is negative 1, negative 5 right there. Now keep in mind, if I wanted to do this the other way, the second way to find that vertex, what I would have done is this. I would have said f of x equals 2x squared plus 4x, and I kind of moved that 3 over. I really want to focus on this binomial. And one easy way to do this is let me factor out the 2. By factoring out that 2, now I can just focus on this binomial and say half of 2 is 1. 1 squared is 1. So I've got to add that 1 there. Now this is a nice, perfect x plus 1 times x plus 1, which is x plus 1 squared. But keep in mind, when I put that plus 1 right there, what I essentially added to this side of the function that wasn't there before was a 2 times 1, which is 2. So if I'm adding in 2, I also need to subtract 2, which gives me that minus 5. And now we see how we can tell what the vertex is. It's negative 1 minus 5. So if I plug negative 1 into this whole thing equals 0. Take away 5 is a negative 5. Now, you're saying, well, what about the other points up here? Where are they? What are they? Well, you know, I could easily see very quickly that if I let x equal 0, I've got a y-intercept of negative 3, which means that I also have that mirror image right there, that reflection, you know, a point right there. So I'm already getting a good idea of what this parabola is doing. It's going up just like this. But, you know, this is a terrible graph, because what I really need to do is find out what happens at 1. So if I plug in the x value 1, I get 2 plus 4, which is 6, take away 3. So wow, at 1, I'm already at 3. So all of a sudden, this bad boy is skyrocketing quickly. And if that point's there, then this point's there. So let me get that bad boy up there. So now we can see, I did not plot the x-intercepts, but I have a pretty good idea where they're at. The x-intercepts are between 0 and 1. How do I know they're between 0 and 1? One of them's right there. Well, f of 0 was equal to negative 3. And then I found out that f of 1 was equal to positive 3. So they're somewhere between 0 and 1, since all graphs of quadratics are continuous. So what we have here, we have some value between 0 and 1 where it is going to be equal to 0. So something's happening right there where it's equal to 0. So how do we find it? Well, most likely, if it's between 0 and 1, it could still be rational, but go ahead and use the quadratic formula. That works every time. And we could find the x-intercepts and actually get a more accurate graph. So keep in mind, what we've done is 2 examples. Simple example, quadratic equation for both of them, and, well, specifically a quadratic function. Found the vertex 2 different ways, put it on the Cartesian coordinate plane, and then used a few other techniques to graph them. Hope this helps. See you next time. Graphing quadratic functions, they're pretty simple and fun.